The first thing we taught you this unit was how to add, subtract, or multiply functions. So let's just try a simple one. F of x is equal to 1 over x, and g of x is equal to x squared. I'd like you to tell me what f times g of x is, and then tell me its domain. Okay, and now it's answer time. So, first of all, you do f times g. You just write the f function. Write the g function. You multiply them together. And fractions don't play nice with other things unless the other things are fractions. So let's make this into a fraction. Put it over 1. Now they will multiply out really nice and easy. So the top stays the top, bottom stays the bottom, and it gets x squared over x. What's wrong with that answer? It should simplify all the way to just x. All right, there's your answer, x. Isn't that weird? Now, if you just look at this one, do you agree if you have the f of x is just equal to x, there would be no things that would crash it? Nothing crashes it. So its domain would be unlimited, and its range would be unlimited. So if you had y equals x, if that was your function, it's a line that goes like this. That's why you can't use the new function to tell what the domain and range of it are. Okay, the domain of it is based on the two parents, f and g. Domain of f, domain of g. How many of you put two number lines on your paper to get the answer for this? Good, then you really get it. Okay? Domain of f is everything except 0. Domain of g is all real numbers. Nothing can crash g. So then, what's the final answer? You overlap them, and you'd say from negative infinity to 0, union with 0 to infinity. There's your domain. Again, some of you might have thought, well, domain of this is just all reals. You can't do that. When you're doing this kind, you have to compare the two parents. All right, when would you ever compare the two parents plus a third number line? Yes? As f over g. All right, I'd like you to do f over g and tell me what its domain is. It'll be totally different. F over g of x and its domain. I'll pause for a second while you try that one. Here we go. F over g. You should have said, okay, the f function, 1 over x, over the g function, x squared. Could you leave it like that? No. We've been practicing this on the top 20. Fraction over a fraction. And what did I just say 2 seconds ago? Fractions will play nice with other fractions. Make this over 1. Now it's easy to see. Fraction over fraction, flip, multiply. Do you know? Okay, what we're doing now is just a reminder on how to overlap the number lines like this. Our last answer was right here, in case I didn't record that. The domain of all three together was right here. And we said that was from negative infinity to 0, union with 0 to infinity. That's for the domain for that guy. And f over g of x simplified down to 1 over x to the third. All right, back to this one we were practicing here. I'm having smartboard issues today, so be patient. There we go. You should have said it works in here. All three of them are dark, so it's negative infinity to 0. And then it works between 0 and 1, doesn't it? If you touch here, here, and here, it hits all 3 times. It's working in all 3 spots from 0 to 1. And then from 1 to infinity. There's your final answer for that one, if you had one like that. Raise your hand if you think you get that. Okay, good. Let's move on. That was finding the simple kinds of domains. What about the more complicated kind, like where you have f of g of x? Let's do that with those same two functions, where f of x is 1 over x and g of x is x squared. Put the one function in the other function and then figure out its domain. I'll pause for a second while you try that. Okay, so it looks like everybody's done here. We're going to get back to it this way. Technical difficulties on the smartboard. There we go. Okay, now we're going to put the g into the f function. I like to write the f function out first then. A lot of people put the g function. I don't think that's smart. I think you should put the f function out with an empty spot, like its stomach. Here's my f function with an empty stomach. And he's going to eat the g function. So the g function here is going to go into his stomach, 1 over x squared. Raise your hand if you had that one right. Okay, good. Now, can I look at this to determine its domain all by itself? No. But when I do look at two number lines, I want the domain of the new function. Some people call it the composite, or some people say domain of the new. And I also want the domain of the inside one. The inside one is the g. This is the inside one. So that's the domain I need for that number line, which is all reals. And then the domain of the composite itself is what would crash this guy, the new function. Yes, something would crash it. 0. If I put a 0 in, I would have a 0 on the bottom, and that would crash it. So it goes like this. 0 does not work, but everything else would. Final answer, from negative infinity to 0, union with 0 to infinity. How many of you would have had that one right? All right, most of you. Okay, any questions on it? It's the part you don't understand. Ask for clarification. Show you're paying attention and you have care. All right. I'm not going to name them, but there's two people listening to the headphones right now. Please take them out, both your ears. Okay, I like the music too, but don't do it during this time. All right, I'm going to now give you another kind. Let's talk about inverses. The inverse of this function, here's this function, x minus 5. What's the inverse of that function? Just find me the inverse. That should be super simple. Then find me its domain. I'll pause for a second while you try this. I'm going to ask you to turn it my way, and I'll tell you if you did it right on the iPad in a minute. So be ready to be accountable for finding its inverse and the domain and range of it. Okay, so first step, make this y equals. Second step, you replace x with y and vice versa. You reverse the x and the y. Next step, you solve for y. So I'm squaring both sides. And x squared equals y minus 5. Now I add 5 to both sides, x squared plus 5. Raise your hand if you had that one right. Okay, awesome. Now, if I take this is just an interesting note. If I were to put in a 9 here, do you get I'd have the square root of 4? The square root of 4 would be 2. That means that the answer is 2. Do you get that 9 comma 2 works in my original function? If I want to be sure that I really made an inverse, I can take, and I bet you if I put in 2 comma 9, it'll work in this new function. If I put in a 2, do you get that it comes out to 9? 2 squared is 4 plus 5 is 9. Now do you get why it works? If you have 9 comma 2, inverses flip x and y. 2 comma 9 ought to work. If you want a way to check yourself on the test, it's a good way. All right. Now, let's go back for a second and say the domain. The domain is based on the domain and range of the original. So I go to this original and I say, what's your domain and range? I like doing it from a sketch. If it's the square root except shifted right 5, it would look something like that. Now the domain of that is not all reals. The domain of that is you have to be 5 or bigger. Okay? I also could have done that by saying take this and set x minus 5 greater than or equal to 0. Add 5, x greater than or equal to 5. Okay, so you can do it from the picture, you can do it from this, but there's my domain. So the domain is all reals except x is greater than or equal to 5. Another way to do that is go like this, 5 to infinity. That's the domain. So what's that become on my new function then? If it was the domain, now it's the range. So everybody check your range, see if you add from 5 to infinity. Raise your hand if you had that one right. Okay, good. And then lastly, the range up above. If I just look at my picture, I like pictures for ranges. From low to high, the lowest is 0, the highest is infinity, 0 to infinity. Can it be 0? Yes. So now that range becomes the domain down here. From 0 to infinity. Questions on that kind? I was finding an inverse and then its domain and range, which come from the parent. And you just flip-flop them. Yes? Do you have to? No. Do you want to get it right? Then I would. All right. So let's do another kind. There's the kind where you prove two things are inverses. All right. Everybody write out that thing you're supposed to know about how to prove two things are inverses. Now here's your f of x. 1 over x plus 1. And here's your g of x. X, that's not how you read an x. X over 7. All right? I'd like you to prove those two are inverses or are not inverses. All right, here's the thing you needed to know. F of g of x was equal to g of f of x. And when you're all done, they better both come out to x if they're inverses. Now, can you just say, oh, I can tell by looking that they're not? Is that proof? No. But you can prove it by doing this. I'm going to stick the g into the f. That means this guy goes into here. So I make him with an empty stomach. 1 over empty spot plus 1. Drop in x over 7. Okay, now, does that equal x? You can't just see it right away. You have to decide by finding, for instance, a common denominator here. All right? Do you agree that 1 is the same as 7 over 7? And now I can add them. 1 over x plus 7 over 7. Now it's a fraction and a fraction. The 1 is not a fraction yet. I'm going to make it 1 over 1 because fractions play nice with other fractions. So now it's 1 over 1 times, flip the other one, 7 over x plus 1, which makes 1 over 1 is just 1. So 1 times 7 over x plus 1 is 7 over x plus 1. Did it simplify down to equal x? Nope. Yeah, it's a 7. Sorry, I was sloppy. I paid a price. And yeah, it should be 7. Okay, but still, some kids are going to go Well, I think it's supposed to equal x, so I'm going to cancel these and say it equals x. Can you cancel those? No, you can't cancel over addition like that. So this one does not work. These were not inverses. All right, let's do one now where it's a little more normal, where it is an inverse. Usually, we're going to give you two functions that are inverses, but I'm not willing to promise you that they for sure are inverses. Yes?
So if you find out the first time that f doesn't work, you have to still prove the second one?
Nope, because once you've proved that one side is not equal to x, it's over. So we did not have to go do the other side. All right, let's make two that might be inverses. 1 over x. How about this? This is f of x. I'd like you to make me the inverse for that. Actually, let's make it 3 over x. Sorry, 3 over x. I'd like you to make me the inverse for that first. Then I'd like you to prove they're really inverses by doing the f of g of x, g of f of x proof. Okay, so first just find its inverse. By the way, they'll abbreviate that as f negative to the negative 1 of x. That means inverse. All right, first thing was three-step process. Y equals 3 over x, x equals 3 over y. Solve for y. Clear the fraction first. Multiplying by y on both sides. xy equals 3. Now I got to solve for y. Divided by x, y equals 3 over x. Ooh, that's weird. Didn't expect that. Came out to the same exact thing as it was in the first place. Is that possible? Yes, it is possible. Now let's prove that it's really true. Well, it's kind of dumb because I have to prove that f of g of x is equal to g of f of x, and if they're the same exact function, it really ought to be equal, but okay. So f of g of x is equal to g of f of x. You put the one inside the other, the g's going into the f, so this one's going into this one, so it's 3 over empty spot, 3 over x, and then I have to simplify that, so 3 over 1. Well, you know what? I can tell it's just going to be x. I'm going to put an x here. Guess what happens when I grade it? Am I wrong? Because you didn't tell me what made that equal x. There is no such thing as canceling this one and this one. And I bet some of you probably just did that on your paper. It was such an easy problem. But yeah, it's about the work. It's about showing me the work. What did I say about fractions? They play nice with other fractions. So I really should have 3 over 1 over 3 over x, and then I can flip and multiply them. 3 over 1 times, flip it, x over 3. And now I can see that these 3's do cancel, and the answer is x. Do you get how a kid could think, oh, I can tell that they're going to work, and so I'm just going to jump right to the x. Okay, that will not work out well for you. Please don't try that. All right, here's the next one. 3 over x plus 1. This is f of x. This is going to be the most interesting of them, I think. And 3 over x minus 1 is g of x. Try proving that those two are or are not inverses. I'll pause for a second while you try that. Okay, in the spirit of keeping things moving, I think I'm going to show you this one. F of g of x equals g of f of x, and then I draw a line like this, and then put the g into the f. This one goes into this one's stomach. 3 over empty spot plus 1, and the empty spot is a 3 over x minus 1. Uh-oh. All right. That's kind of complicated. Well, that's why it's going to be an R3. If you have this level of question, it's just the R3 style where you have to, okay, you only have to answer 4 like this, so. All right, can you handle it? What, can you just go, oh, minus 1 and plus 1 cancel? No, those don't cancel first. Okay, you have to do it in the right order. The order of operations, please excuse my dear Aunt Sally, means that parentheses, which is what this is all in here, this is in big parentheses. The fraction symbol, fraction bar is a grouping symbol, so that's like a giant parenthesis. That has to be first. So your first step is you handle this part, which is make this a 3 over 1 over 3 over x minus 1. Then it's still got a plus 1 on the outside. I'm pretty sure it's not. This right here came from right there. It's all right. I'm glad you asked because I do make plenty of mistakes. So. All right, so now I'm going to flip and multiply. 3 over 1 times, flip it, x minus 1 over 3. And now I still have a plus 1 out here. This is going to definitely tax your algebra skills. Now can I cancel plus 1 minus 1? No. There's a multiply and a divide, which come before. And then they add and subtract are the last thing that can cancel. Your final answer is x, but it had to be done in the right order. Okay, if you didn't do such an awesome job of that one, then better go back up and try your g of f of x again. I'm going to pause for just a second and let you do that. Now, if you've already done it and you already know you did it right, go ahead and do something else for a minute. I want a minute for people to try g of f of x, showing it the right way. You watch me do it, you think you're going to remember it. There's only a 10% chance you actually will. It's by doing that you remember. If I had had you do something last week with your hand span, you probably remembered it right now. If you just do it once, you remember the, oh yeah, it was 7 or 8, or was it 9? So easy to forget. All right, so you should have put the f into the g. So I take the g first, start with g, 3 over empty spot minus 1, and drop in to the empty stomach the f that got eaten. That's this guy. And so it's 3 over x plus 1. Once again, it's all about what you can cancel first. I know the 3's are going to cancel. I know the 1's are going to cancel. You do it in the wrong order, you're going to get it wrong. You got to start on the inside. What's the inside? Well, there's kind of like parentheses around this whole thing, and there's definitely parentheses around that. That makes those parentheses within parentheses, which makes them the most important thing. So you do not start with the 3. You start with the plus and minus 1 can be canceled off. And now I'll have 3 over x. And then I got to know to make that into fraction, so it plays nice with other fractions, make it over 1. So now I can rewrite that as 3 over 1 times x over 3. Now the 3's can cancel. Final answer is an x. Yay. X and on that side and an x on this side. Technical issues, sorry. There was an x down there. That proves that you have two functions. Sorry. Functions that are inverses. Okay. One last kind. I know it's your favorite. Find its inverse and find its domain. I'm going to pause for a second. Okay, so here we go on, sorry, computer issues here. Wow, that's really frustrating. Okay, this one is f of x, so I'm going to change that to a y, and then I'm going to change x and y around. X equals y plus 4 over y minus 5. Which of my sayings comes in handy here? Starts with clear. Clear the fraction. You really want to clear the fraction. So you start by multiplying by y minus 5. Cancels. Then I'm going to multiply it out. xy minus 5x equals y plus 4. Very common for people to forget the 5x. We just put a 5 there by accident because people forget to distribute to both parts. Then I got to get my y's all onto one side. X, y, so I'm subtracting y from both sides. xy minus y minus 5x equals 4. Now I got to get the y's all alone, so this needs to get out of here and go over there. xy minus y equals positive 5x plus 4. Then I have to, this is the stroke of genius moment. Since I've told you a few times it won't be a stroke of genius, but if you can factor it, you should. And this is the part a lot of people get stuck on. Y comes out, you have x minus 1 left. And then you can divide by x minus 4, or x minus 1. And you have y equals 5x plus 4 over x minus 1. Bingo, bango, bongo. Raise your hand if you had that one right. Good. That's more than half of you, so you have a chance. Now the domain, of course, we have to go back to the original one and find the domain of the in range of the original. It's not a piece of cake. Domain of this puppy depends on its denominator. So the domain is all reals except 5, so I'm going to go this way. Can't be 5. Could I have written that interval notation? Sure. I will at the end. And the range of it. Remember, the range is all about going up and down. What stops you from going up and down? A horizontal asymptote. Who tells you about horizontal asymptotes when you have fractions? Bob does. And is this a bigger on bottom, bigger on top, or same on both? Same on both. So the same on both kind is a ratio of the lead coefficients, which is a y equals 1. So everything except 1. I like to do it this way. Here's a 1. Everything except that. So how do you overlap them? No, this is not about overlapping them. This is just about what is the domain and range of the inverse. So I take the domain here and it becomes the range of this inverse at the bottom. And I take the range and it becomes the domain. All right, so my domain is now the range, which is the range was negative infinity to 1. Union 1 to infinity. And then the range comes from the domain, which is from negative infinity till 5, union with 5 to infinity. That's a lot of math. And that covers a really thorough review of what you're supposed to know by now. So your homework is a worksheet I'm going to hand you, and then it's got all the answers posted. So that's all I have for you for today. All right.